here I have a linear inequality in two variables, and I want to graph the set of all points that make it true. So for example, the point 0, 0 here, if I plug in 0 for x and 0 for y, I end up with 0 is greater than 2. That's false. On the other hand, if I were to plug in, say, negative 2, 1, let's see, negative 2 times 4, negative 4, no, negative 8 plus 2 is negative 6. So I would get 1 is greater than negative 6. So that is false too. So how do we figure out which points make it true? So a couple things to consider. One, if I ignore the inequality, this is a line. So I need to graph that line. It's a boundary in this system. And then two, I need to figure out which side of the line to look at. Other thing to consider is that since this is a greater than, it's not equal to, points in the line won't work. So I want to use a dashed line instead of a solid line. Solid line would indicate that the points on the line do make it true. That would mean I have maybe a greater than or equal to, but I don't here. So switching to a dotted line, I can graph this by using the slope-intercept idea. So the y-intercept is 0, 2. And the slope says to go up 4 and right 1, or I could go down 1, 2, 3, 4, and left 1. So here I have my line. And again, from this lower point, if I go, oops, I accidentally plotted an extra point. Oh no, it's ready for me to work. If I go up 4 and over 1, okay, so I definitely have the right line. Now I need to figure out which side to go on. Now earlier I tried to plug in 0, 0, and I ended up with a problem. And when I plugged in negative 2, 1, I got 1 is greater than negative 6. So that's true. That's good. So this side is true because when I plugged in, say, this point right here, I got a true value out of this. So I can check with some other ones. So the point 0, 4 seems to be on the shaded region. So if I plug in 0 for x, I get 2 on the right side, and y is 4. 4 is greater than 2. So what we're going to find is that any point in the shaded region that we plug in for x and y here will give us a true inequality. Any point on the other side I plug in should be false. So just double checking 3, 3, for example. 3 times 4 is 12, plus 2 is 14. Y would be 3. This would say 3 is greater than 14. Well, that's false. It's a good thing it's false because it's in the unshaded area. So I believe I have a correct solution there. I can submit it and see. I got a green light. Another one. Jump to number 10. All right, here I have a greater than or equal to. That means I'm going to use a solid line instead of a dotted line. So the dotted line is for just strictly less than or strictly greater than. Solid line is for less than or equal to or greater than or equal to. So first step would be to plot the line. So I need 2 points on this line. I'm going to use the y-intercept. So that would be negative 3, 0, or 0, negative 3, sorry. And then the slope says go down 2 over 1 because it's a slope of negative 2. So that's my line. Next, I need to figure out which side to go on. Now, generally, if I have a choice, I like plugging in 0, 0. Let's try it. So if x is 0, I'm going to get negative 3 on the right. Y is 0, then the inequality says 0 is greater than or equal to negative 3. That's true. So that leads me to believe I should shade this side. So then I just do a couple of other test points to see. What if I were to plug in, say, 1, 1? It should be true because it's in the shaded area. So if x is 1, I'll get negative 5 on the right. 1 is greater than or equal to negative 5. That's true. Let's try something on the other side, like over here, negative 3, negative 3. If I plug in negative 3, negative times a negative is a positive. 6 minus 3 would be 3. Y is negative 3. Is it true that negative 3 is greater than or equal to 3? That's false. It's in the non-shaded area. Every point in the non-shaded area should lead to a false situation when I plug the x and y in. Every point in the shaded area should lead to a true. But what if I pick a point on the line? Like here it says 1, negative 5 is on the line. So if I plug in 1 here, I'll get negative 2 minus 3 is negative 5. Y is also negative 5, so my statement says negative 5 is greater than or equal to negative 5. So there's the or equal to part. The equal to part is the line. I think I'm looking good. I tested a bunch of points. Submit. Cool. Now I'm playing around on the homework and I'm testing these points in my head. It's a good idea to write those tests down on paper, especially if it's a quiz or a test. So have fun, do good graphing, see you in the future.